All right, if you're a public health student, maybe you're gearing up for exams, this one's for you. Think of this as your personal study guide, where we're going to break down the absolute must-know essentials of statistics. So here's our game plan. We'll kick things off with the big why, what your real goal is as a consumer of science. Then we'll get our hands dirty with the fundamental building blocks, the different types of data. From there, we'll figure out how to find the center of that data with the 3 M's. And finally, we'll wrap it all up into a neat toolkit you can take with you.
Okay, first things first, let's get our heads in the right space. Why are we even learning this stuff? Well, the goal is not, I repeat, not, to turn you into a full-blown statistician. It's actually something way more practical for your future career.
And here it is, plain and simple. Your goal is to be an intelligent consumer of science. Because let's be real, in your public health career, you are going to be swimming in studies, reports, and data every single day. Your job is to know what the numbers are really saying and, just as important, to spot when they might be trying to fool you. We've all been there, right? Staring at a study and it feels exactly like this cartoon. There's data, there's a conclusion, and then in the middle it just says, and then a miracle occurs. Well, our whole mission here is to demystify that step too, making every part of the process crystal clear. So let's start laying the foundation. Every single analysis, from the most basic to the ridiculously complex, starts right here, with understanding your raw materials. And in our world, that means understanding the data itself. At the very top level, pretty much all data falls into two big buckets. You can just think of it as word data versus number data. On the left, you have qualitative data, also called categorical. This describes things, qualities or characteristics. On the right, you've got quantitative data, or numerical. And that's all about things you can measure with numbers. Okay, let's dive into that first bucket, qualitative data. This is all about sorting information into groups. And within this family, there are two key flavors you've really got to know, nominal and ordinal. And this is the perfect way to see the difference. Look at nominal data on the left, blood types. Type A isn't higher or better than type O, right? They're just different labels. There's no inherent order. But now look at ordinal data on the right. With kidney disease stages, order definitely matters. Stage 2 is worse than stage 1. There's a meaningful sequence there. Now for that second big bucket, quantitative data. This is the stuff we can count or measure. And yep, you guessed it. This one also breaks down into two main types you'll see all the time, discrete and continuous. And this illustrates the difference perfectly. Discrete data is things you can count in whole numbers. You can have 2 car accidents, or 3, but you can't have 2.5 accidents. Continuous data, on the other hand, can take on any value within a range. Someone's weight isn't just 150 or 151 pounds. It could be 150.75 or 150.753, and so on. Okay, pop quiz time. Let's put this into practice. Here's a real table from a public health study. Look closely at the age category column. So, what do you think? Is it nominal or is it ordinal? I'll give you a second. If you said ordinal, you are absolutely right. Why? Because those categories have a clear, logical order to them. Awesome. So now you can identify different types of data out in the wild. That's a huge first step. But the next question is, what do we do with it? Well, the first thing we almost always want to do is summarize it to find its center or its most typical value. And for that job, we have 3 main tools in our statistical toolkit. And lucky for us, they're super easy to remember because they all start with M. We call them the 3 M's. The mean, the median, and the mode. So let's pop the hood on each one of these. Because here's the secret. It's not enough just to know what they are. The real skill for any public health professional is knowing when to use each one. It's all about choosing the right tool for the right job. Let's start with the one everybody already knows, the mean. This is just the fancy scientific name for the good old-fashioned average that you learned about in grade school. And yep, the calculation is exactly as simple as you remember it. You just add up all the numbers in your list, then divide by how many numbers you had. That's it, nice and easy. But, and this is a really big but, the mean has a major weakness. It has a kryptonite. It is super sensitive to extreme values, what we call outliers. Think about it. If you have 9 patients who stay in the hospital for 5 days, and 1 patient who stays for 300 days, that one person is going to yank the mean stay way up, and it won't really represent a typical patient anymore. And that problem is exactly why we have our second DEM, the median. The median is our hero when those pesky outliers show up. You just line up all your numbers from smallest to largest, and the median is simply the one smack dab in the middle. And here's the median's superpower. It completely ignores those crazy high or low values. It doesn't care about that patient with the 300-day stay. It only cares about what's in the middle. This makes it a much more trustworthy measure when you're looking at things that can be skewed, like income or home prices. And finally, our third M is the mode. And this one is by far the simplest of the bunch. The mode is just the value that shows up most often. That's it, the most frequent one. So when do you use this? Well, think back to our categorical data. You can't calculate the average blood type, can you? That makes no sense. But you can absolutely find the most common blood type in a group of patients, and when you do that, you're finding the mode.
Okay, let's pull all this together and officially add these concepts to your growing public health toolkit. Seriously, this is the foundational knowledge that will let you start looking at data with real confidence.
So for your notes, here's the bottom line. Data comes in two main families, words and numbers. Each family has its own kids, like nominal, ordinal, and so on. To find the center of your data, you've got your 3 M's. And the most important takeaway of all, knowing which M to use and when, that's the real mark of a pro. So I'll leave you with this final thought experiment. You read a report that talks about the average income in a neighborhood, but you happen to know a few billionaires live there. Which M do you think that report is using? Is it giving you the real story? And which M would you trust more to tell you what's really going on? Answering questions like that, well, that is what being an intelligent consumer of science is all about.